So today we are going to start with a very important thing, that is the reactions of benzene. And I want every one of you to be focused up here, because whatever the mechanism I'm teaching you, that mechanism will assist you a lot. Okay, so let's start with the reactions of benzene. Okay, okay, my dear students, the first thing, benzene undergo the reaction which is called as the electrophilic substitution. Okay, electrophilic substitution, or this is called as the ES reactions. Okay, so ES reactions. So before starting this electrophilic substitution, I'm considering that you people don't know about electrophile or nucleophile. So from the fresh way, I'm going to tell you first of all a little bit about the electrophile and nucleophile, and then I'm going to come up here again. Okay, so we got the two terms. The first term, that is electrophile. Okay, electrophile, and we got nucleophile. Okay, so these two are the terms. The word electrophile, the word electro comes from electron. Okay, and the word file means lover. Okay, electron lover. Electron lover means electron got the negative charge on them. So if anything loves electron, what does it mean? It is having the positive charge on it. So the first thing, my dear students, the electrophiles, they are positively charged. They got +1 or +2 charge like that. Okay. The second thing, if you got a polar molecule like partial negative and partial positive, so the partial positive part of a molecule, that is also acting as a electrophile. Okay, so you got the positive charge or you got the partial positive charge. So these things, they would act as the electrophile. Okay, now move towards the nucleophile. The word nucleo means nucleus. Okay, nucleus got the positive charge on it. And the word file means lover. So nucleus lover, nucleus means positive charge. So if anything loves the nucleus, if anything loves the positive, so it means it is having the negative charge on it. So nucleophile, normally they are negatively charged. The first thing, nucleophile may be neutral but should contain the lone pair of electron. And we got a polar molecule, so partial negative part, that is also acting as the nucleophile. But in all of these three cases, these species should contain the lone pair of electrons. Okay, then these species, my dear, they would act as a nucleophile. Okay, so it means electrophile, they are positively charged. So it means in the benzene, the electrophilic substitution means that the electrophile, that is positive or partial positive. Okay, so anything which wants to react with the benzene, it should be electrophile. Electrophile means should have positive charge or partial positive charge. Is it clear, my dear? Yes, sir. Okay.
Yes, sir.
Okay, my dear, now everybody just listen these words very carefully, please. Okay, I'm going to take the benzene up here. This is the benzene. So this is benzene. The first thing, benzene is normally stable. It does not want to react with anything. And what is the reason behind it? Due to the delocalization of its pi electron. Okay, its pi bonds, they are always changing their position. Okay, so that is why benzene is very stable and it does not want to react with something. Okay, so write down this thing, benzene is stable So the first point, benzene is stable due to delocalization of its pi electrons. Okay. So benzene is stable due to delocalization of its pi electrons. Okay. So it does not want to react with something. But if you want something to react with the benzene, so that thing should be some electrophile. Okay. So if you got the benzene and something wants to react with the benzene, that thing should be some electrophile. But there is one problem that every electrophile cannot react with the benzene. Okay. What electrophile then can react? Okay. Electrophile, here I'm going to use the word abnormal. So abnormal, you got an abnormal electrophile. Abnormal electrophile. Okay. So abnormal, I think every one of you are well aware with the word abnormal. If I'm going to say someone that he's abnormal, abnormal mean mad. Okay, some you can say like a crazy type of the thing. Okay, so not a normal electrophile can react with the benzene. If you want to react something with the benzene, so that thing should be some abnormal electrophile. Okay. So abnormal word means what is meant by the abnormal. So let me tell you, explain this thing. Any one of you could tell me what the charge chlorine has? Negative charge. So chlorine is having the
Minus negative.
minus charge. Minus charge means chlorine is the member of group 7. It is having the 6 electrons, sorry, 7 electrons of its own, and 1 electron has been taken from something else, so it got negative charge on it. But due to some reason, if chlorine, my dear, it got positive charge like that. So positive charge means that its own electron that has been taken by something else. So this El positive, this Cl positive, that is the abnormal electrophile. This is the abnormal one. Cl is normally not the positively charged. Cl is normally negative charged. But if due to some reason the Cl gets positively charged, so this electrophile is not normal. This is abnormal. This is crazy electrophile. So these kind of the crazy electrophile, they can attack on the benzene. So what they do, they come close to the benzene and they say to the benzene, oh benzene, give me 2 electrons. But benzene, he's stable. He say, oh, I am stable. Due to delocalization of my pi electron, I can't give you electron. But this is not normal electrophile. He is going to say to him, come on man, I'm asking you, give me 2 electrons. But this benzene does not bother. He said, come on, go away, get out. I don't want to give you electron. Why should I give you? I'm stable. Now, what does this electrophile do? It is going to collide with the benzene, striking with the benzene so powerfully that the benzene, start thinking, "Oh my God, this one is going to explode me. This one is going to break me." He say, "Oh, come on, man, stop! I'm going to give you electron." Okay. So now, what would happen, beta? This is these are the electrons. Okay. So this one, this pair of electron, okay, is given from this ring towards this electrophile. So every benzene has got this type of the mechanism. Okay. So this one is given to it. Now what would happen after giving the pair of electron to the electrophile? So what would happen? every corner we got carbon and hydrogen. Okay, so the electrophile would be attached up here, and this ring that would break down and would be expanded to the five carbons only, and the positive charge of this thing would come up here. So this is the unstable complex which is being formed. Okay, so listen again. This electrophile is going to collide with the benzene so powerfully that the benzene is going to stop him and say, please stop. I'm going to give you a pair of electrons and give it a pair of electrons from the pi electrons. So you should make a curly arrow like this one. You should start the curly arrow from this ring and make it towards the positively charged. Now, this ring would break down and would be extended to the five carbons only. On one side, every corner has got one carbon and one hydrogen. Okay, so this electrophile is attached up here. This one will become unstable complex. So this benzene say to the electrophile, see man, I have given you electron, but now I have become unstable. So this electrophile, you know that he's mad. He say, what should I do? So this benzene, what does it do? It is going to snatch the electron of this hydrogen, okay? Because hydrogen is very innocent, okay? So the ring that would be completed again like that. Electrophile is attached up here, and H positive that would come out. So one of the positive ion that has attacked on the benzene, and one of the positive ion that has come out. Okay, so these type of the reactions, my dear. So this is the mechanism which is being used in all benzene reactions. Okay, so this whole reaction that is called as the electrophilic substitution. Okay, so this is also called as the ES reaction. Okay, my dear students, now what we are going to do, we are going to start with the reactions of benzene. Keep remember benzene could react with the four substances only. Okay, so benzene can react with number one, chlorine, Cl2. Number two, bromine, that is Br2. And number three, the halogen derivative. Halogen derivative means beta any compound having the halogen inside it. Okay, so it could be anything. Okay, so that is called as the halogen derivative. And the last thing, my dear, that is the nitric acid. Nitric acid. Okay, so these four reactions they could take place with the benzene. Okay, and keep remember, I will ask you about the reactions of benzene. So keep remember, benzene can only react with the four substances, only four substances: chlorine, bromine, halogen derivative, and nitric acid. Okay, by the same mechanism I told you. So one by one, we are going to discuss those mechanisms.
हाइड्रोजन डेरिवेटिव क्या है
जी
हाइड्रोजन डेरिवेटिव क्या है
हाइड्रोजन डेरिवेटिव
जी सर
बताया तो है भाई, कोई भी कंपाउंड जिसमें हाइड्रोजन लगा हो, क्लोरीन, ब्रोमीन, आयोडीन लगा हो, कोई भी हो, ठीक है जी।
ठीक है
Okay, my dear, so let's start with the first reaction, that is reaction with chlorine. Reaction with chlorine. Okay, my dear students. So everyone, just listen now. You have to just listen this whole reaction very carefully, because I'm going to explain this whole reaction in a very precise manner so you can get every aspect of this one. Okay, so first of all, this is the benzene. Okay, so this one is going to react with the chlorine. Any one of you could tell me, can Cl2 could react with the benzene? No, until it has been changed into some Come on. Abnormal
Right.
electrophile. So nothing could react with the benzene until it has been changed into some abnormal electrophile. To make it abnormal electrophile, we use a catalyst which is called as the AlCl3. We can use AlBr3. We can use FeCl3. So these three catalysts they are used, but I would suggest you use this one AlCl3. This is more powerful, but you can use these two as well. Okay, in the paper sometimes he could write AlBr3 and FeCl3 as well. Okay, so first of all, what is the function of this AlCl3? What is the function of it? The function of this AlCl3 is to make it abnormal electrophile. So how does it make it? Everybody just listen. This Cl3 has got this dot and cross diagram like that. You know that chlorine that is the member of group 7. So it has shared one of electron up here. So the 6 electrons are present like that. So 6 electrons are present like that. 6 electrons are present like that. Okay. So this aluminium, if you look at the aluminium, it has got 6 electrons in its valence shell. Okay, so now what would happen? This chlorine, my dear, the chlorine. So one of the chlorine I am going to draw this white dot, and one of the chlorine I am taking the crosses for this chlorine. Okay, so now what would happen? This chlorine will give its lone pair to the aluminium, and what does it do? It is going to snatch the electron of this chlorine as well. So what you will get? What you will get? So this AlCl3 and this Cl would become AlCl4 minus. Okay, and this Cl would become Cl positive. Okay, so in the paper you don't need to draw this whole diagram. You can write it like that. AlCl3, it would react with Cl2. So one of the Cl would be attached up here. So AlCl4 negative and Cl positive. So this abnormal electrophile that has been generated. Did you get it? Online students, did you get it, beta?
Sir, can you explain again?
Beta, I told you this is AlCl3. Al has no complete octet. You know that I told you in the A1 that its valence shell has got 3 electrons, and due to covalent character, its covalent bond that is being formed. So it has got 6 electrons in its valence shell. So octet is not complete. So this chlorine molecule gives its lone pair, to this aluminium and snatch the electron of this chlorine white, okay, and come close to it. So this one will become AlCl3 and this here AlCl4 negative. Why? Because this white electron is the chlorine, this chlorine electron. So AlCl4 negative and this Cl electron has been snatched, so it would become Cl positive. So in short word, you can write it AlCl3, Cl2, so AlCl4 negative and Cl positive. So abnormal electrophile has been generated. Did you get it? Fatma?
Yes, sir.
Okay, my dear. So this is the benzene. Okay, so this is Cl positive. This is the abnormal electrophile. So this is abnormal electrophile now attack with the benzene. So from the ring towards the Cl positive, you should make a curly arrow, and then the ring of the benzene that would break down to 5 carbons. Here Cl is attached. Here hydrogen is present. From here the electrons are given back to it. So the ring that would be completed again. Okay, and we got Cl attached up here and H positive that is being produced. Okay, so now up here this AlCl4 negative, it will break down again to form AlCl3. So catalyst is generated again and Cl negative. So this Cl negative and this H positive, both of them they would join together to form HCl. So the overall reaction would be this is benzene and Cl would be attached to it, and HCl that is being produced. So this is the overall reaction, and this whole is the mechanism to operate this reaction. So you should know this mechanism as well as this mechanism. Did you get it? Yes. So now what you are supposed to do, आप लोग क्या करें? Do the same reaction, use the same catalyst, and do the reaction with bromine Br2. At the place of bromine, you should write Br2, and other method is almost same. So I'm going to give you 5 minutes. Okay, guys. Now everybody just listen. That how people are going to do this type of the question. So you should practice all these things at your home. So I'm going to take bromine this time. So Br2. So I'm going to draw the bromine up here. These are the two bromine atoms, white, and I'm going to take the square one. So white electrons, okay, and the square electrons like that. Because we got this time 1, 2, 3, three different types of the atoms. So this is cross, this is dot, this is shaded dot. So I want to take these two electrons separately, or you can take white dot of this one as well. Yeah, it's okay, white dot. Take the white dot of this one. Okay, so what does this bromine do? It is going to give its lone pair to this AlCl3 and snatch the electron of this bromine as well. So it would become AlCl3 and Br. This whole thing would become negatively charged. Okay, and this Br would become positively charged. Okay, now this AlCl3. So this Br positive is going to attack up here. Okay. So this is Br and the Br is attached up here. Okay. And then this AlCl3 Br negative would break down to form AlCl3 and Br negative. So this Br negative and H positive, they would form HBr and Br would be attached up here. So this is the whole reaction happening. You can write it AlCl3 plus Br2. So this is AlCl3Br negative plus Br positive. Okay, so you can write this whole equation in a simplified form like that. So beta,
Yes, sir.
I want all of you to practice these two reactions again. Okay, do these two reactions 3 or 4 times so that you should know that how to make this whole mechanism. Okay, so that's it for today from my side.